Okay, so we're going to work on a couple steps here. Uh, when you guys go to do a 2D sketch and you're trying to do a lot of different kinds of relations, um, it's there's a lot of different pieces to the puzzle. So I'm going to start with something like a center point arc to anchor one side of our drawing. This will not be to exact dimensions or anything like that. This is just going to be from approximate memory of the general principles. Um, for the French curve, you've got some starting point. Um, you've got an ending point for each arc. There's going to be a lot of these 3-point arcs. So you start by selecting the center point, then you start by selecting one point where the arc starts, then another point. Then there can be a few others that will show up. I'm going to reset our view so that we're square here. I'm going to do some made up dimensions in order to make this work the way that I'm expecting it to. I'm going to pull up that reference guide. Nah, I'm going to do it by memory. Never mind. So what we're going to do is set up another arc. And let's see. There is, I know, a starting point up here. There is, I'm going to do an approximate likeness, and then we'll kind of go from there. So I'm going to do things that are not necessarily exact to what you guys are working on for the assignment, but show the general principles of what's happening. So I'm going to do a 3-point arc, and you start with the end points, and you come up with a curve that attaches them. So usually in this case, it's a large radius difference. Maybe this height is different by about, let's see, maybe this height is different by about 45 millimeters. Maybe this has a radius of 12. Maybe this one has a radius of 32. This has a radius of 335. There's a couple other things that are going to be helpful in getting a sketch like this fully defined. We'll talk about those because there's going to be a few curves that are going to happen. So there's going to be another 3-point curve. In this case, I'm probably, yeah. So I'm going to do, it'll be easier with a few 3-point curves than some other geometries. So these, I don't want the endpoints to necessarily be equivalent. So this one, maybe it's a 90-degree arc, and I'll show you how to specify some of these. And we'll have some more folks jumping in and out as we go. So getting a couple of these um, definitions, getting um, you'll set some sort of a radius, but you can also set an arc as part of it. So we'll say 15.5 millimeters, and we want to know what the arc length is often, or that's something that we want to be paying attention to. There we go. We got a few more jumping in still. Um, we will show how to kind of define these arcs. There's a couple other things that we can use as reference points. So far, only the partial arc here is fully defined because it knows its origin is at the origin. We're going to do another couple 3-point arcs. Um, because we can specify some of these details. Um, there's usually some kind of a reference that you have to do for these. So I'm going to zoom in. You really need to be able to make use of the zoom in and zoom out. So if you haven't gotten yourself a mouse yet, this is the assignment to get a mouse for. Because if you can't zoom in and zoom out on different parts of your drawings, you're really going to be hurting. So this is actually going to be a short arc. So again, this one will be 90 degrees. This one's going to be a little bit less. Then we're going to close this geometry. So that'll be 90 degrees. So you want to be able to make fine-tune adjustments to these. Okay, that one's going to be slightly more than 90 degrees. We're going to do another one. But I don't want that same association. So being able to manipulate these, some of them are going to be, I'm going to leave as 90s just to show how to get full definition on a shape of this variety. There we go. We need another arc here. So maybe something not quite 90, but pretty close. So maybe something sort of like this. So we're going to create a couple pieces of the puzzle overall. This is, again, not exactly what you guys are doing, but you will get the general gist of how this works. There is there are a couple ways to do some of these things. You can do Center lines for reference. Those will be helpful. So you may need a couple of them. I don't want to associate any of the end points with other points on the drawing because I'm going to move those around. You might need this to be different by, say, 25 degrees or something like that, right? So you can set the angle difference relative to a center line at 25 degrees. And you can do it at other angles and things as well. But if you do it that way, what you can do is then do another center line, and you can make it parallel to that one. And you can bring it down here through the part as needed. I just want to not have it associated with any of these other anchor points or reference points because I want to change all the dimensions of those. And I want to say the angle difference between these two, I want to set to 0. Nope. That's difference. So I want to set the angle reference to 0. So that's okay. Then I can click and drag and set that where I want it in the drawing once I've set that reference. It'll kick this dimension way out here. What you can then do is you can select that dimension and hit delete. So this is one of the secrets of this particular project, is being able to move an object around and then delete that dimension so that it stays where it is. And then you can add something like an ellipse or a slot, should you have to do such a thing. And that would stay on your center line. And a slot similarly might be something like that. Maybe those two are both at an angle with respect to the part. You could do another center line and move this with an angle reference as needed. So this one, maybe this needed to be rotated or something like that. What you could do is you could take this, you could add a line down the center, and you can say, well, I want the difference between these things to be, instead of 180 degrees, maybe I want them to be a different value. It's going to tell you I can't do that because the points on that ellipse have a center line association. So what you would actually have to do is set that ellipse at its own angle and add another angle reference. So you would move this using the smart dimension and say, maybe that needs to be 35 degrees or something of that nature. And then I need another center line that allows me to have a different orientation even still. And this one of the other ways you can do it is you can be sort of clever and associate the end points, but it's going to try and give you some other association with one of these other anchor points, and that's what you don't want to do typically. So we look at the angle between them, and we want them to be 180 degrees. And then we can click and drag. You can click and drag that down, and maybe we need it to be here so that we can then do a slot that's at only a 25-degree angle or something like that. So all right, apologies, lots of chaos going on here. And make sure nobody had a disconnection issue. Okay, there we go. So what we can do with these angle references is set up conditions where we can have multiple different rotational angles. Once we've set up the objects that we need under these conditions, what we can do is then go and we can from there, once we've got the angle set and this one is at the position we need it to be, we can move this with the smart dimensions to say, actually, this needs to be exactly 35.42 or whatever distance that needs to be, and 5.21 millimeters here. Once we've done that, we can take this, we get out of the smart dimension tool using the escape key. You can then delete the center line, and that'll help at least get a good start. So what this will do is this will delete some of the references. If it's in your way for some reason or something like that, that's an issue. These you can't really hide them as easily. The center lines are always going to be there, but if for some reason it's in your way and it's creating problems, I'll show you what it looks like. You can delete it. That will get rid of and clear some of those references, but it will leave your part, or that part of the part, in the same angle reference, which is okay. So there's a couple different ways to deal with the spacing and arrangement there. When you're trying to do a cutout section, for instance, maybe we've got another, let's say another 3-point arc here, and maybe this one, maybe this is just a little bit too long, and that distance actually needs to be 17.25, and we need to move this. We need to move this down by, there's a couple ways that we can do it. We can also do a manual movement of the whole object along that center line and get it closer to where we need it to be, depending on what we're trying to do for that. So there's a couple ways that we can handle that, that will maintain some of those angle relations. As we lock down more and more pieces, more and more dimensions, it will continue to have some movement. So another thing that we can do here is we can do this. So we start the arc at the very top, bring it down to the very bottom. Then we start another midpoint arc here, and then we start maybe a 3-point arc because we want it to be reduced diameter at this end or something of that nature. So we set the reference point. In this case, we could use another center point arc there. It's going to be tricky to kind of figure out how to position it. A 3-point arc lets us position that without having to already know what the height difference is on the center line there. Then here again, we could do another center point arc and kind of guess. We can do a 3-point arc and get it exact to get the space that we need for a geometry like this. So once you have kind of all of the rough pieces in place for drawing like this, what we're going to start doing is setting some of the smart dimensions. And this is where a lot of the questions come in for some of the examples here, just because of how much chaos there is going on. So we need to know what the dimensions are and how these are going to work together. Referencing the center point of another arc, or referencing preferably the origin, is going to be best. So if we need to know, we need to be able to set the distance between these and maybe it's exactly 132.2. Okay, then we need to set the distance. So now you can see just by setting the distance, we've got a vertical and we've got a horizontal distance for the center point of those arcs relative to the um, origin. That's important to be able to reference. So now this curve is fully defined because it understands where that end is. Okay, so the center lines we don't have to have fully defined. We're not really focused on those. But maybe for an ellipse, we need to have dimensions across. There we go. So maybe you need to specify the dimensions across here, and maybe it's exactly 10 by let's say 18. Maybe it's 10 by 18 or something like that. The dimensions here, you get an approximate thickness of maybe 6.53 or whatever that dimension is. The particulars here I'm not super duper focused on, but now I need some reference point to get a dimension established so that I can set. It's going to be even better if I can do the arc. So the ending point is an even more valuable target point. The difference is sometimes if we've got a, so right now because we have this in place, if I can specify the ending point for one of the arcs and then specify the radius. So we check each part of the definition. The other thing that we need is a vertical reference point in order to get one of the other key references that we need. So maybe that needs to be exactly 18. And then this guy, needs to have 180 degree. So you can specify down here the angle of the arc, the number of degrees in a particular arc length, so 180 degrees, and leave the radius at like 19.3. Hit OK to keep that. This arc, we're going to need, again, 180 degrees. So you want to probably specify that first. And then a radius of 25.25 maybe. Hit OK. Even if that messes with some of your dimensions, what you can do is bring things back into alignment using a reference like this, where you bring it down and you say, I'm going to move that point into the center line here by saying 0. Okay. I'm going to move this point into alignment with the center line by hitting 0. So this arc now, I want to be 180 degrees. But there may be a couple other definitional things that you need there. So instead, I'm going to bring this closer to the top using the 0 reference. And by slowly but surely moving all of these, what I can do is I can specify, so this has a radius of 4.34, so maybe I want that to be exactly 4.34, and that radius relative to the center point here needs to be 20.9 exactly, or something like that. This, because of our arcs and definitions and changing some of these values, has now shifted. That's okay for the purposes of right now. We're trying to show how each of these can be moved. So this one, now maybe I can tell it I actually only want an arc length of 180, but that's going to disrupt these other radii. So the radius that it stores in memory is 14 and 18 are the two that are fighting. So I'm going to drop that and come back over to, okay. So I'm going to hit Control Z to go one step back, so we're not trying to overdefine the arc. But with the other references in place, now I have full definition of this slot. I have full definition of this feature. The other thing, so we've got a distance horizontally, center line. We need a distance. We've got a distance vertically and horizontally from the center line. These are a little bit more tricky to get fully defined. And I forget, there's a couple kind of hints on the sheet when we go to make this. Nope, I don't want that view. I want the top view, or yeah, top view. Nope, that is bottom view. Why is this fighting today? Top view. There we go. Back to top view. So it can become kind of a messy hodgepodge of things. Some of these reference points you can then delete if you need to, but then that'll change your definition. So you just have to be a little bit careful on what those values are. So for this, we're going to specify a radius. So this is already constrained. So I'm going to cancel that. We don't need a constraint here. What we do need, so it's already got a defined radius, so we've already got that. What we do need is we might need just a linear dimension to specify the arc length or something of that nature. I'm going to step out of this tool because we've now got an over definition going on. So our arc length is not helpful, but our endpoint height, let's see, that's going to tell us an over definition on the radius of 32. So we're going to delete that one. This one, I think I've got two. Yeah, I've got two smart dimensions on that one, so that's why it's yellow. We've already got 35. The difference is we want to know what the total length, the total arc length of this is, or the the number of degrees this spans. So maybe we actually only want this to be, so maybe this dimension we want to delete, and we want to specify the arc length this way by saying, hey, we actually only want this to be a 25-degree span, and that will adjust the radius accordingly. So we hit OK, and we note where that ends up. So we've now got a specification of both the radius and the arc length, and we're going to do something similar for these guys. This probably the only other difference is it's going to look for something like let's try again, smart dimension. Sometimes you have to step out of the tool because reasons. So it'll allow you to specify a height. Maybe it needs to be exactly 247.75 or something like that. Then, yeah, maybe we need to do one more and do a vertical. So both a vertical and a horizontal. Sometimes it needs both. For arc lengths specifically, it's most helpful. So maybe we can do 214 even. So for arc lengths like that, having a reference back to the origin or having a reference back to the center point of another arc is usually enough, at least in terms of the horizontal. So maybe we want that exactly 29.5. And we've got the radius specified already. So the other thing that we need to specify is ideally the height. So 37.2. Okay, so we have this arc segment defined. So now we can sometimes reference this one, and maybe we want it to be 8.5. And we want the height to be 6.65 millimeters. Then the only thing to specify is the radius, 4.7. So this would invalidate the geometry. So in this case, I'm going to undo that. And because I've already constrained some of the other geometries, that alteration, get rid of that center point reference, especially when you're doing the assignment on this particular shape. You want to use the escape key often to get yourself out of that smart dimension tool. Okay. Same deal here. Maybe we actually want 5.45 as the radius. And again, we can do a reference now based off of this other center point, 2.25. And so hit the check mark to accept that. Smart Dimension's behaving a little strangely this morning, but I guess that's to be expected. So then the last one, for these kinds of arc segments, one of the dimensions, you're just going to have to accept whatever the further decimal places is. So this one, the radius, sure, 31.5. Let's make it exactly 31.5. Actually, let's make it 31.6. There we go. So we could again reference off of this point. we could go back and reference off of this point, depending on what kind of dimension we've got. There's some different examples of what we could be doing there. Same deal, setting a reference point here for height. Maybe we want it exactly at 22. Okay, so that part of the curve is now fully defined. Same thing here. We need a radius. Okay, and maybe for this arc, we need to define the height relative to the other end point. And maybe it's exactly 5.44. Okay. Then we would need to, again, specify some other distance. So maybe the end point is 34.4. See if we can do that without breaking it. 34.4 millimeters away from the center line. We've got the height difference between these, and now we need the horizontal distance between them or something like that as a reference point. So now that one is fixed without having actually referenced the center line either. We just need to establish exactly where one endpoint is with both X and Y, and then the last missing reference between those 2 points in order to specify the endpoints of the arc. That's how we do that. So it's the same kind of thing here. Maybe you have another height and it's exactly 5. And maybe you have an endpoint here to here distance at 63.49. Okay, 63.49. And we specify a radius, 5.18. Okay, so now this one's fully defined. It's a lot easier if we get to use the center points for these arcs. But again, the objective here is to be able to show you the process by which, especially now that that endpoint is established, we can say the difference between this endpoint and this endpoint now needs to only be 3.42. Okay. And maybe the vertical distance between, so hit OK, go back into the smart dimension. This also highlights the need to save early, save often. So maybe this is 26.45. And now the radius is whatever fits for the other criteria. So we just hit a OK, and we've defined the radius, and now we've got full definition for here. It can be tricky to get kind of the last few things fully defined, so I'll try and show you how to make sure those happen. So this one, again, radius 2.1 is probably good. We'll do a radius on this curve, 1.6. We'll do a radius on this curve about 14.64. Okay. Then another thing that has to happen is still some sort of reference point. 33.32. Height difference of, we'll say, 11.43 exactly. So that's constraining this arc, but there's still some flexibility for this arc. So maybe we have that intersection point defined as being exactly 8.7 millimeters away. horizontally, and then vertically, this height needs to be 8.6 exactly. So we've specified that one. We now have the end point here. So we might need to specify the height difference, or you might need to zoom in and specify the horizontal distance, or in this case, the horizontal distance is going to be easier to get full definition for that piece. So same sort of thing here. Get us a radius, we'll say 3. Get us another radius, we'll say 2. Bring that down. Get us another radius, we'll say 15.7. 26.2. Set that exactly, 26.2. And maybe again, we have an endpoint definition where we've got 25.85, 5.85, and another endpoint definition. The height-wise, we're at 3.11. So this endpoint we have specified. This endpoint we might need to specify again. So setting that height, once you've specified one endpoint, it helps to lock things down. Specified here, main thing we need is maybe the horizontal distance and the vertical distance. Or we could have done, again, an XY reference. So the pattern there is exactly the same for getting the horizontal difference. This one, I think what we need is an angle reference. This is kind of a more complex angle reference. So what I did there is specified 3 points. The ellipses are strange because of this. Because you've specified the diameter for the first one and the diameter for the second one, if you try and tell it the radius for each side, it's going to tell you over definition. But you can reference a center point, and this is also something that you can do without doing some of the other things. We've already specified an XY height. The only thing that we're looking for is we want to know what angle we're using here, and it will change our orientation of the circle or of the ellipse. So what we want is maybe 160 degrees as our reference point. And that 3-point angle change is going to be the easiest way to get something like an ellipse out in random space fully defined. If you hit the center point with X and Y dimensions and then do a 3-point angle like I just showed you. And that's how you get to full definition. So you want to maybe move around the notations a little bit. Once you've done the smart dimensioning, you can reposition these in order to make them more visible a little bit. You want to do a little bit of rearranging to try and make it easy for me to see what you guys have done in terms of these. But I want to make sure that we're making stuff right for you, um, and understand how to make this cooperate with all of these different dimensions. So really paying attention to X and Y, specifying radius, specifying endpoint distances. That's how you're going to get from one end to the other. Okay, so it's a lot of information. Questions on this? Let's do a clarity scale check to make sure A, you're still alive, and B, you're still functional. Um, 1 being dirt with no water, 10 being holy water. Where are we at on that clarity scale? Somewhere around like a 3 or a 4 is an OG Gatorade flavor. Crystal Light's probably somewhere around like an 8. So let's see where we're at. Okay, we might be averaging somewhere around a 6 or 7. So that's pretty good. I know there's a couple of you that are going to have to go back and rewatch this and get a better sense of what I'm doing exactly. Um, the goal here is to work your way through kind of from one end to the other, setting dimensions and boundaries. Um, so for those that are struggling to understand what it was that I was doing there, what are the main points of confusion for you as far as setting some of these smart dimensions? Because this referencing is just a step-by-step procedure. So what are some of the questions that are coming up? Or, hey, could you go do this one again, or something like that? So I'll give you guys a minute or two to type. Um, I'll go back and make a couple changes here, um, as if there was a dimension that we were like, oh man, I completely got that one wrong. That way we can see what it is that you would do about it. So maybe this one, for instance, um, you had wrong, and oh, that's not actually how the original one looks. That endpoint we need to be able to move, but in order to do that, you can't just grab that endpoint and move it around because it's already fully defined. So we would need to get rid of this dimension. So that would free up part of this endpoint. We would also have to change this dimension for 12. Now you'll notice, since I deleted that radius, this one is no longer fully defined, because even though we know where the endpoints are, it hasn't been fully defined in the right way. So this endpoint we can now shift a little bit. Um, for this one, I want to see if I can. There we go. You can sometimes reposition manually. It can create kind of some hardship for you, but what you can do is a you can specify an arc length, or if you're really, really, really having trouble, what you can do is you can delete that reference. What you can do is you can actually delete that circle. The trouble is, if you do that, you're going to lose a lot of definition for if you've based a lot of other components on that. You can lose a lot of definitions for things. General lack of confidence is fair. These are a little bit crazy to try and work with. These are kind of an interesting process because this endpoint here is constrained by this definition. This dimension is also creating some of the fight. So now I have control again over the endpoints. In this case, there's one other, I think there's one other association. We can bring this arc length down manually. So we could say, what if I did this? The trouble is we're fighting one more definition here. Let me see if I can move this guy. So yeah, that's this is the other couple dimensions that are constraining our movement here. So I'm going to delete those real quick in order to get back control over this one point. So all four of those dimensions were constraining this point. So if you're trying to recreate the arc at the back and you're saying, oh, well, it doesn't make a sharp corner right there. The whole point of the French curve tool is it's supposed to be like a free-form curve tool, and it's supposed to, generally sort of make sense. There's a couple ways that can happen. So there is a specific relation for how this curve looks relative to everything else. And I'm not going to spend a whole lot more time on it. But now, if you've corrected some error, then you go back and you just respecify. So now, okay, this is radius 11.01. So now that part's fully defined. We can specify again an endpoint height here. It's going to be easiest if we specify a height here to the center point of that radius. This one, we need the radius value and then maybe a horizontal distance value to fix this point. The only other thing now we need is this endpoint fixed. So maybe we want that totally lined up, and you might have to zoom in really, really closely to get a vertical. There we go. And maybe you want that to be exactly 0. So you fix the end point of that arc. The arc segments are sometimes easier to fix, and we didn't have to mess with the center point there, and we got back to full definition. Okay, so that's how to change something and then get it back to full definition once you're all done. All right. Questions on this? Or is this at least sort of starting to make sense in a crazy sort of way? Again, this isn't exactly the same dimensions as the part that you guys are creating, but this will give you an idea how to do working away from one end to the other using references. The reference dimensions on this assignment are much, much easier to deal with. But when you guys are going to turn this assignment in, this is something that I want to see the sketch get to a place of being fully defined. So I want to see you guys able to reach this kind of a state. If you've got one line or something, one curve that you just cannot figure out how to get it defined, that's okay. But broadly speaking, what we want to do is get these up and running in a more meaningful way for you. Okay. So the recording should be ready later today for this. So I know you guys are going to need it in order to reference. I think there's also another 340 video that shows another shape that's very similar, same kind of idea, kind of walking you through how to get to full definition. So there are other resources and other videos posted to the YouTube channel in a playlist for you guys to follow up with. So there's some room to make some of this work. Other questions at the moment? The large arc on top. Yes, the arc on top is difficult. That's something that you may have to just sort of do by that one can be a little bit more by feel in terms of getting it into approximate alignment. I'm going to pull up that dimension sheet that you guys are given. Yeah, you're given a very simplified version of this. Yeah, and you're given some endpoints. Another couple keys that you might need for this are going to be using center lines. Let me show a couple more examples of these. The center lines on all of these, the way that they're set up, so the sheet that you have doesn't have anywhere near this level of dimensioning. Those key dimensions that we show, we want you to go ahead and familiarize yourself with those dimensions and make sure that you're able to show them on the finished part. But one of the easiest things to do, especially for this end of it, is you will probably want some kind of center line. And let me see if I can get it. Yeah. So this is a center line that'll go through that circle. You can then do a center line here, and you can specify the angle and say, all right, I want the angle. So again, clicking somewhere along that line, not like a midpoint to midpoint, because that'll give you a vertical distance. Maybe this angle needs to be 25 degrees. Maybe you need another one at 30 degrees or something like that, where this needs to intersect. And you say, okay, between this line and this line needs to be, maybe it's 40 degrees exactly. and you need the end point of this. You need this meeting, this arc to meet there. If you set those center lines first, what you can end up doing is using that as a reference point when you go to create the arc that you need to piece it together. So there's a few different ways, and it also shows on that sheet, it shows some close-ups. Basically what they're doing there is they're zooming in to like this bottom foot, and then they're zooming into the top of this one or something like that. I forget what the exact two views are, but they zoom in to tell you this little arc segment has a radius of 10. This arc segment has a radius of whatever. They're trying to show you some fine detail, so it's not like an additional object. You don't have to draw those circles separately. And I've had students message me, wait, what dimension are those big circles? That's not actually part of the drawing. That's just a highlight to show you some smaller features that are a little harder to focus on. Okay. So this does give you the key techniques and pieces to work your way through geometry like this and what's needed. Again, center lines are really going to be your friend on this, so that will help make things much more reasonable. So this is a good place to pause for a minute and check in for questions generally. I know there's a bunch of Halo messages that I need to get caught up on. So I'll try and see if I can get to more of those today and see if I can get more of the assignments graded, since those should have been done and turned back around days ago, but they haven't been. So I'll work on getting that up to date, so that you guys know where you stand points wise. But in the meantime, what other questions do you guys have? From the center point to the point of the arc rather than the center line. So if you specify an angle, putting some sort of a center line from a center point to the end point of an arc, you can specify that way. The key is really just making sure that when you're adding these center lines, what you're just paying attention to the fact that you know you have established this point as being where it needs to be. Because if I were to change this value, this 45 height, if I were to try and change this value and move that point around, the center points and everything else would move relative to that point, but it would break a lot of other associations. So a lot of other dimensions, most of them would be invalidated if I changed that height, because so much is referencing that point. So whenever possible, you want to try and reference stuff back to the origin, just so that you don't lose all of that work on your structure or your part. If something happens and you realize, oh man, I blew that was actually supposed to be 47 millimeters, then it's a whole lot easier to make changes if most things are referencing this point. Because the interesting thing about this is this center line here, 25 degrees here or 40 degrees here, is the same as a center line at 40 degrees over here, right? And then you could make a so like we can demonstrate that just by saying the angle between this center line and the other center line. Again, We need center lines in order to set angles well. So 40 degrees over here and 40 degrees over here is the same thing. So we can set up this and then say, I want to add a center line here, and I'm going to drag it all the way through the part. But I want to first start by setting the angle between them. Another one that you can do is you can set the physical distance endpoint to endpoint to be at one end, maybe it's 70, and then set the angle difference to be 0. So now you've got a reference and you say, oh, okay, we're just a little bit off. So I actually need to add maybe 2 millimeters to that or something of that nature. So maybe this is 72 and we're pretty close. Maybe it's 72.1 or whatever it is, right? The point is you can keep refining that dimension. You can keep refining that dimension until you get your interaction that you're looking for. You can also delete that reference and then do the measurement up there, but you can set center lines relative to the origin and then change stuff about your part without losing the rest of that reference. So there's a lot of ways that you can approach it, and that's part of what I'm trying to teach you guys today is how many different approaches you can have with it. All right. Other questions? Yeah, Fusion is a different sort of workflow than this. Fusion is based in some AutoCAD traditions that's a little bit different, and other drawing packages have their own peculiarities. So this is something that you just have to learn to do the SolidWorks stuff the SolidWorks way. The Smart Dimension is how to get things to work the SolidWorks way, and Smart Dimension is your friend. Whereas in a lot of other languages, a lot of other drawing packages, you have to sort of specify some of the details there. So, all right. Other questions? Are you guys getting to be a little bit more confident with this? I have a few more minutes here to work with. So I'm going to go ahead and stop the recording for this part, and then we'll see about jumping to